video tutorial series of the wireless communication. I am our instructor Varshata. Let's start our today's lecture series. So at the end of this video, you will be able to learn about the GSM speech coding, and then we will learn about the air interface in the GSM. So GSM, that stands for the Global System for Mobile Communication. So architecture of the GSM, how GSM works, how we can do the routing in the GSM, that all we have done already. So let's see how GSM speech coding is occurred. So what is GSM speech coding? So speech signal is the most important part of the GSM mobile communication. Thus the speech coding technology and the high efficiency digital modulation technology can provide a higher system capacity for the digital mobile network than the analog mobile network. Okay, so speech signal is the most important part of the GSM. This technology that provide the high efficiency digital modulation, and it's provide the high system capacity for the digital mobile network. Now here you can see this is the figure for the GSM speech coding. What are the steps that perform in the GSM speech coding? So first step is the speech coding, and after that the channel coding will perform. After that interleaving will perform, and then the burst formatting is there. After that ciphering is there, and then the modulation is there. Okay, so what is the meaning of this each and every steps? Let's see in detail. But whatever the steps that is performed at the transmitter side, the same steps will be performed in reverse at the receiver side. Okay, if we are doing the modulation, that means we have to do the demodulation. That means if you are modulating the signal, you have to demodulate it, otherwise the receiver cannot understand it. So demodulation is also necessary. If you are doing the ciphering, deciphering is also necessary. Suppose ABC is your text and you are converting it by adding the 3 ASCII value in A, 3 ASCII value in B's ASCII value, and 3 ASCII value in C's ASCII value, like this way. So what will be the output of this? ABC. Then the encrypted text is DEF, because we are adding the 3 ASCII value in it. So this text that becomes the cipher text. Now it cannot be understood by the receiver until and unless the receiver knows about the keys that is used to encrypt the data. Okay, so this deciphering should also be done. So now let's see what are the steps that is involved in the GSM speech coding. So first of all, the first step is speech coding is there. Okay, so here the GSM speech and speech coder, that is known as the RELP. So RELP, that is residually excited predictive coder, which is enhanced by including a long-term predictor, that is known as the LTP. Okay, the coder provides the 260 bits for 20 milliseconds blocks of the speech, which aids the bit rate of 13 kbps. GSM speech operates in the discontinuous transmission mode. In short, it is known as the DTX. Okay, so by incorporating the voice activity detector, that is VAD, in speech coder. So this mode provides the longer battery life. It reduces the instantaneous radio interference. So since GSM transmitter is not active during the silent periods. Now a comfort noise subsystem, that is known as the CNS, is used at the receiver, which adds the background acoustic noise to compensate for the annoying switch muting which occur due to DTX. So receiver side, this acoustic noise background should be used to to remove the noise. Okay, so this is what the speech coding. Now next is what the channel coding. So the output of the speech coder are ordered into for the error protection based upon that significance in contributing the groups to the speech quality. So over the 260 bits in the frame, the most important 50 bits, that is called 1A bits. 1A bit is there, 2A bit is there, that we will see in that frame structure. It has the 3 parity check bits added. That is the cyclic redundancy check. All of you know what is the cyclic redundancy check, that you have learned in the CN. Okay, so these 3 parity check bits added to them to detect the non-correctable errors at the receiver side. The next 132 bits with the first 53 bits are appended by the 4 trailing 0. So this providing a data block of 189 bits. So this block is then encoded for the error protection using the rate half convolution encoder with the constant length of k is equal to 5. So it provides the total 378 bits in this channel coding. So like this way channel coding is performed. Now here you can see the least important 78 bit is do not have the error protection and concatenated to existing sequence to form a block of the 456 bits in the 20 milliseconds frames data rate of speech signal becomes 22.8 kilobytes per second. So here in this figure you can see this criteria. Type 1A bit is that is the total 50 bit. Type 2 1B bit is that is 132 bits, and type 2 bit is that is a 78 bits. Okay, now we are adding the parity check bit, that is using the CRC, that is using the cyclic redundancy check. So here the total 3 bit is added in the type 1A bit. Okay, now this convolution code rate, that is a half constraint that contains the length total 5. So total 378 bits are there. Okay, so this 378 bits and type 2 bit is added, that is a 78 bit. So 456 bits for 29 milliseconds speech frame. So to transmit this bits, it requires 29 millisecond to transmit the 456 bits. Now interleaving. Now what is the meaning of the interleaving? To minimize the effect of the sudden fades on the received data. Sudden fades, that means it may be any atmospheric effect is there, or any data change can be occurred. So to minimize this effect, interleaving is performed. So the total of the 456 encoded bits within the each 20 millisecond speech frame or control the message frame are broken into 857 bits subblock. So total subblocks will be defined and its size is 57 bits, and they are numbered even or according to the block numbers. So these 8 consecutive blocks are spread over the 8 consecutive this traffic channel time slot, that is known as the TCH slot. Okay. Now if burst is lost due to the interference or fading channel coding ensures that enough bits will still be received correctly to allow the error correction to work. So if burst data will lost, this will be performed. Now each traffic channel time slots carries 257 bit blocks of the data from 2 different 20 millisecond speech blocks. Okay, so at a time it can carry 257 bits block. So time slots of the first 4 frames contains even data blocks of the present speech frame and odd data block of the previous speech frame. Now the time slots of the next 4 frames contains odd blocks of the present speech frame and even data block of the next speech frame. So this is the interleaving that is performed during the GSM speech coding when data is transferred from one station to the another station. Now next is a burst formatting. So what is burst formatting? Burst formatting, that means it adds the binary data to the block to help the synchronization and equalization of the received signal. To define the synchronization, at whatever the speed the sender is sending the data, the receiver can also receive the data. So synchronization purpose, we are adding this burst data. Then next one is the ciphering. So as I given the example of the cipher text, that ABC is converted to the DEF because we are adding the 3 ASCII value in each and every character. So what is this? This is the ciphering. So deciphering should be done at the receiver side. Got it? So ciphering modifies the content of the 8 interleaved blocks by encryption techniques known to the particular mobile station and the base receiver station. And in ciphering we are using the different 3 algorithms, that is A3 algorithm, A5 algorithm and A8 algorithm. A3 algorithm, that is the ciphering algorithm. A5 algorithm, that is again the ciphering algorithm that is used for the encryption. A3 is used for the authentication purpose and A8 is used for generating the cipher key. So as I told you, the 3 is the cipher key to converting ABC to DEF. Okay, so same way, if you want to convert the DEF into original text, you have to -3 in the ASCII value of the DEF. So you will get the original key. So same way, this key will be used at the receiver side to decrypt the data. Got it? So this 3 algorithm used during the ciphering. A3 is used for the authentication purpose, A5 is used for the encryption purpose, and A8 is used for the ciphering key generation purpose. Now next is the modulation. Okay, so signals are transmitted over the air. Okay, so the modulation should be required. So which modulation techniques we are using in the speech coding? So we are using 0.3 GMSK, that is Gaussian minimum shift keying modulation. So where 0.3 describes the 3 decibel bandwidth of the Gaussian pulse shaping filter. The channel data rate of the GSM is the 270.833 kbps, which is 4 times the radio frequency shift. So this minimizes the bandwidth of the modulation spectrum, hence it improves the channel capacity. Here the MSK modulated signal is then passed through the Gaussian filter to smooth the rapid frequency transmission, which would otherwise spread the energy in the adjacent channel. Okay, so here we are using the Gaussian filter. Why Gaussian filter? Because to smooth that particular rapid frequency, so it cannot affect the adjacent frequency, it cannot generate the adjacent interference. Okay, there are basically two types of interferences are there that we will study later: co-channel interference and adjacent interference. So if we will not use the Gaussian filter, it will produce the adjacent interference. So to remove that adjacent interference, we should have to use the Gaussian filter to smooth the data. Now next is the demodulation. So the portion of the transmitted forward channel signal which is of the interest to a particular user is determined by the assigned TS, and the FCM, the appropriate TS, is demodulated with the aid of the synchronization data that is provided by the burst formatting. Okay, so burst formatting, that means we are adding the extra data for the synchronization purpose. So after demodulation, the binary information is deciphered, de-interleaved, and channel decoded, and the speech decoded. So at the receiver side, we have to decode it, we have to demodulate it. Now next topic is the air interface in the GSM. This air interface is also known as the interface, radio frequency interface in the GSM. So let's learn about this. So the interface is the air interface for the GSM mobile telephone standard. It is the interface between the mobile station and the base transceiver station. Okay, so it is the interface between the mobile station and BTS. So the interface between these two devices is known as the air interface or the interface. So it is called the because it is the mobile analog to U interface of the ISDN, that is Integrated Service Digital Network. So this air interface or RF interface uses the time division multiple access, that is TDM. Okay, so technique to transmit and receive the traffic and signaling information between the GSMs, BTS and the GSM mobile station. Okay, so this use the traffic and signaling informations between GSM, BTS, that is the base transceiver station, and mobile station. Now the TDM technique, that is a time division multiple access technique, is used to divide each carrier into 8 time slots. So these time slots are then assigned to the specific users, allowing up to the 8 conversations to be handled simultaneously by the same carrier. Okay, so 8 conversations can be handled by the same carrier. 8 channel can be allocated to the particular mobile station or to the particular base station. So the International Telecommunication Union, that is ITU, which manages the allocation of the radio spectrum, has allocated the following bands or the GSM air interface. Here the two frequencies is used, that is uplink frequency and downlink frequency. What is uplink frequency? That is 890 to 915. That is the uplink frequency, that means mobile station to the base station. Downlink, that means base station to mobile station. So that is known as the downlink frequency. So 935 to 960, that is the downlink frequency, that is the base station to the mobile station. Now here you can see this is the figure that is representing the air interface in the GSM. So here you can see this is the mobile station is there. After that BTS is there. As you have learned the GSM architecture, so it will be easy for you to understand. The mobile station is there. Mobile station sends the signals to the BTS. BTS sends to the BSC. After that MSC is there, and MSC transfers the signals to the another network, or in the same network is there. Then again the MSC will transfer this to the BSC, then BTS, and then mobile station is there. Okay, so here air interface is there, then base station subsystem is there. In base station subsystem, BTS is that. Okay, so this interface you can see over here, that is between mobile station and the base transceiver system. And here BSC, that is base station controller, is that, and after that MSC is that, that is a mobile switching center. Now the air interface involves both the physical and the data link layer, that is layer 1 and layer 2 of the OSI model. So all of you are about the OSI model. So it contains the two layers, that is the physical layer and the data link layer of the OSI model. The physical connection of an air interface is generally radio based. So this is usually a point-to-point link between an active base station and the mobile base station. Okay, so it's defined in physical connection. Physical connection, that means what? Point-to-point connection is there. Physical connection is there. Okay, so physical connection of an air interface is generally radio based and it is a point-to-point connection. Multiple links can be created in the limited spectrum through the frequency division multiple access, time division multiple access, and the space division multiple access. Now, next is the data link layer. So the data link layer is in air interface is often divided further than the simple media access control and the logical link control sublayer that is found in the OSI terminology. Okay, the MAC layer is there and LLC layer is there. So while the MAC sublayer is generally unmodified, the LLC sublayer is subdivided into 2 or more additional sublayers depending on the standards. Okay, so the common sublayer include, that is the radio link control, packet data conversion protocol, radio resource control. Okay, so these are the common sublayers that is included in the data link layer. So in this video we have learned about the GSM speech coding. Okay, GSM speech coding, different steps are there that is performed, like modulation, demodulation, then ciphering, deciphering. Okay, speech coding is there, channel coding is there, bus formatting is there, interleaving is there. Okay, so these are the steps that is involved in this GSM speech coding. And then we have learned about the air interface in the GSM. Okay, so air interface, that is between the mobile station and the base station, and how this will be performed. Air interface contains the 2 layers of the OSI model, that is the physical layer and the data link layer. So this is all about this lecture. Remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture. Thank you.